When we write a processing sketch, we often care about the precise location and shape and colors of many of the objects on the screen, and so we create those things very carefully and put them where we want them. There are other times, though, when we want to have a large number of additional objects, and we don't care about the precise details that describe each object. When that's the case, we can use processing's random number generator to crank out all kinds of numbers so that all of these objects will be slightly different from one another and they'll look a little bit more interesting than if they were all the same. Here's an example. In this little sketch, I'm drawing 300 circles on the screen simultaneously, and they're all moving around just a little bit. If any circle moves completely off the window, it just reappears somewhere within the graphics window. Now, if I had to type in the center and radius and color of every single one of these 300 circles by hand, it would take forever and it would be just the most boring program in the world to write. So instead, I just have a tiny little loop. I run through the loop 300 times, and each time through, I make one additional circle. And I use processing's random number generator to crank out a random location and radius and color. I save those pieces of information in arrays, which we'll talk about in another video, so that I can use them again from frame to frame. But it's the random numbers that are doing all the work in creating these circles. So let's see how to use random numbers. We generate random numbers one at a time. We ask it for a random value, and we get back a float. The only thing we have to tell processing is the range of the float. We tell it the low and high values, and we get back a number somewhere between them. Here's how. I'll declare a floating point variable called a, and now I'll fill it with a random number from 0 to 1. That's all there is to it. We just call random with the values 0 to 1, and we get back a value between 0 and 1. We can hand random any two numbers, 500.2, 8,123. We can hand it negative numbers, negative 1,500 to positive 1,500. It doesn't matter, you'll get back a number in that range. The key thing you have to remember, though, is the first number has to be smaller than the second one. That's really kind of unfortunate, but that's the way it is. So remember, the first number has to be smaller than the second, and you will get back an unpredictable number somewhere in that range. Here's something that we do all the time, and I did in the sketch I just showed you. We find the center of some object by asking for a random number between 0 and the width of our graphics window, and the y value is a random number between 0 and the height of the graphics window. With these two calls, the variables cx and cy identify a random point somewhere in the window. In these examples, cx and cy are floats, and random is a float. There are times when you want to use random to generate an integer, like maybe you're going to roll a die and you want a number from 1 to 6. There's a little subtlety you have to keep in mind. Suppose you write something like this. Starting at the right side, we ask for a random number between 1 and 6. And then we ask for the integer part of that. That just throws away everything to the right of the decimal point. Then we take that number and stick it into die roll, which is an integer. So it would be reasonable to think that by asking for a random number from 1 to 6 and throwing away the fractional part, we would get back numbers from 1 to 6. But in fact, as you can see in the comment, we really only get back the numbers 1 through 5. Let me show you why so you understand the problem, and I'll show you how to take care of it. Here's a number line, and I'll identify each point on the line with this little vertical line. When we ask processing for a random number between 1 and 6, it says, I will give you a number that might be as small as 1. It could be exactly 1, but that's very unlikely, but it's possible. And the numbers will go up, 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 until they reach 5.9999999, but they'll never make it to 6. And you can see here in the graphics, there's just a little gap between the right-hand side of this yellow box and the number 6. You'll never get back 6. The biggest number you'll ever get back is 5.9999999. So if you take those numbers and throw away the fractional parts, you get back the numbers 1 through 5. Because 5.99999, throw away the 9s, all you have is 5. So if you want a random number between 1 and 6, what do? You don't do this. Instead, think of it this way. If we ask for a random number between 1 and 7, then we'll get back numbers between 1 and 6.9999999. Throw away the fractional part, and we get back numbers between 1 and 6. So in the special case, when you want to generate an integer, you're going to want to ask for a random number between 1 and 1 more than the integer you want. So here's the template at the bottom. If you want a number between 1 and 6, you ask for a random number between 1 and 7, and you take the integer part of that. That's the recipe for the special case when you want to generate integers. When you want a floating point number, this tiny little discrepancy between what you're asking for and what you get back really doesn't make any difference at all. So let's look at a few examples of generating random numbers in different ranges. Here's our number line, and if we ask for a number between 1 and 5, no problem. If we ask a number between 4 and 8, sure, we'll get back random numbers between 4 and 8. Well, actually between 4 and 7.99999, but except for the special case when we're making integers, we usually ignore the tiny gap at the end and think of the results as spanning the whole range. We can also ask for negative values. Remember, the number that comes first in the range has to be smaller, and -3 is smaller than 1. It's to the left of 1 on the number line. Think of the little arrow. As long as the arrow from the first number to the second number is pointing to the right, you are great. The random number range can span negative and positive. So here we'll get a random number between -1.5 all the way up to 6.5. Really, processing doesn't care. Here's one place where it's easy to get tripped up. Suppose you're asking for a random value between two negative numbers. Remember, -3 is less than -1. It's more negative. The arrow between -3 and -1 points to the right. So that's the right way to write it. If you get the numbers in the wrong order in any of these examples, you'll only get back the first number always. So for example, look at the yellow box on the bottom. If I said random 5, 1, we would always get back the value 5. It's really unfortunate, but that's the way it is. So remember, the first number always has to be smaller than the second. Earlier, we saw an example of asking for a random number between 0 and width, and so graphically it would look like this. So let's look at a couple of examples of random numbers in action. Here's the jittery ball program I showed you before, and using the keyboard, I can actually crank up how much they jitter on every frame, and I'm just using a wider range of random numbers on every frame to move these things around by bigger and bigger amounts. In this example, and the others in this video, I'm using arrays so that I can remember my random numbers from one frame to the next. But the key work in making something like this happen is the random number generator. Here's a kaleidoscope made out of random circles. I just crank out random circles of different sizes and colors. I start them in the center, and I give them sort of a direction, but that direction is random, and the direction itself even changes. And you can see these things are leaving behind little wiggly paths as they move away from the center. By using bigger random numbers, I could make those paths wiggle much, much more. Here's a little raindrop program. The shapes, the colors, the sizes, these are all determined by random numbers, and then I just let the raindrops fall. You'll notice that the bigger ones are falling a little bit faster than the smaller ones, which gives it a little bit of a sense of depth. Each time a raindrop disappears off the bottom of the screen, it starts off again just above the top in a new random location with a new random size and a new random color, so the pattern never repeats. We'll see how to write a program like this when we look at arrays. Arrays give us a means of remembering these random numbers from one frame to the next, so we have some continuity. If we didn't have any continuity and we generated a new set of raindrops on every frame, we could do it, but it would look crazy. This is what we get if we generate new raindrops on every frame. Well, it's kind of interesting, but it has no continuity at all because there's no continuity in random numbers. Every time we ask for a value, we get back something completely unpredictable in that range. I like the version with continuity better. I find this a more pleasing animation. But still, the shapes and sizes and colors are all coming from random numbers.